some of the classification algorithms, namely maybe the very basic one called a Naive-Bayes classifier, and maybe the decision what is called support vector machine, and then KNN classifier. You might have seen these simple classification algorithms. So if you take maybe some point of time, I might have discussed in the ANN architectures when I was talking about different ANN models. We started with the MLPN and MLFFN, and we discussed RBFN and PNN. So we have discussed so many architectures related to the ANN for the classification and regression problem. Right. If you look at those things, what is that knowledge? How do I interpret the knowledge? So the knowledge is all about the weights. The knowledge is all about the hyperparameter tuning. So when you fine tune, the fine tuning is all depends on the problem to problem, data to data. So there is no global parameter values that accepts all sort of the solves all sort of problems. Okay. Yeah. So if you look at what is the knowledge in that, how do I interpret the knowledge? Because we train the model for acquiring the knowledge to represent. Okay, so how once we acquire the knowledge, how do we represent the knowledge? So the knowledge is represented with the help of the weights, right? See carefully in the it's called whiteboard. So the knowledge is in the form of the weights. So that is called it's a weight is also one of the hyperparameter, and you look at ANNs, and if you take any more hyperparameters, so weights this ANNs, the weights that represents the knowledge. The knowledge is being represented in the form of the weights. If you're taking the Naive-Bayes classifier and the KNN, the hyperparameters in the Naive-Bayes, of course there is no hyperparameter, but where in the case of KNN, the hyperparameter will represents the knowledge. Right. By looking at these values, what are these weights and these hyperparameter values? What are all these? These are simply values, the numerical values. By looking at these values, we cannot interpret anything. We cannot interpret anything. It means that interpretation means like I don't get any knowledge. I mean, by looking at these values, we don't know how the knowledge is being represented and what kind of knowledge is being represented. So that's the reason people have used a rule-based classification algorithm. Rule-based classification algorithm, and whatever we discussed so far, these are all called non-rule based classification algorithm. So in the rule-based classification algorithm, the knowledge is represented in the form of if, then, come. If something happened, if some criteria is missed, then this is the decision. The decision. By looking at this, so the end user can easily interpret the knowledge, what sort of knowledge is acquired by your model. So that's the importance of the rule-based classification algorithm. So in order to generate the rules, so one of the way is to first construct the decision trees. So one of the two is the construct the decision tree. In the second step, you can do the rule generation. You can generate the the construct the decision tree, then we can generate the rules. We will see how we can generate the rules once we construct the decision tree. Now let us focus on how to construct the decision tree and what the decision tree it is. So we will study about those things in the today class. Then I will at last I will try to connect all these things. What is the rule based classifications? How it is related to rule based classification as well. So if you look at, so this everybody knows, if any classification task, if I take it, so we will partition the data set into training and testing. And mainly the training is used for building the model. Here the model is nothing but your decision tree, right? Because we are focusing on our decision tree, the model is decision tree. So once the decision tree is built, so we will test this decision tree. With the help of test data, we can test this decision tree, how well we have trained, how well you acquire the knowledge from the data, right? Now, if you another important thing over here is, if you observe this data set, we have a three attributes, three features, and one class label. And this a class label is a binary class of sort either some S or no class. Any sample is will classify into either S class or the no class. Oh, this is not required now. Now, let's see how a sample decision tree the look like, how the sample decision tree look like. So let us take the same example. So where the attribute 1 is the, say, the refund, and the attribute 2 is the marital status, and attribute is taxable income. So based on three attributes, I want to classify a given a person is a cheater or not, if a given a person a cheater or not. So if you train the neural network, yes, we can do with the help of neural network to classify this, to achieve this classification task. But thing is, the knowledge is invisible. We cannot see the knowledge. But here in this case, if you look at a sample decision tree, so why it is called a tree? So it is the data is being organized in a tree data structure, which is you most of the people study in computer science in the data structures, and we are using this tree for making the decisions. That means the decision is with classification task, whether it's S class or no class. That's why it is called a decision tree. So what are the some typical characteristics of this decision tree? What sort of data is storing in internal nodes? What sort of the data is storing at the leaf nodes? That is very, very important. If you carefully observe the what sort of data is being stored inside this internal nodes, if you look at here, the internal nodes are nothing but your features. One second. Sorry. So if you carefully observe, the internal nodes are the features. These are all nothing but your the features. If you look at, these are the features. And where the leaf nodes, if you see the leaf nodes or the, what are they? The class information, the class labels, the ground truth information. Right. Now, if you see, this is one sample decision tree. So this class labels, and they are at the leaf levels, and the features are at the what is called internal nodes. And how we this decision tree. So once we organize the data in such a way, so how we can make use it for the decision making process, I will explain soon. So let's see, this is one sample decision tree. Okay, but there is a possibility that there could be more than one the decision trees in your for your given data set. Now let's see. So the question is how we can make use it for the decision making process once we have some sample decision tree with. So we will see how we can construct the decision tree. So now we assume that the decision tree has been constructed from the training data set. Now how we can make use for the identification or the class label of cheater, whether cheater or not. So now let's see what is the, how can we choose that. What are the reference status is no. So start from the root. So the reference status is yes or no. So the root. So go to the left right branch. Now, what the marital status? The marital status is married. So go to the right branch over here. You're saying that if the married, you will go to the right branch. And if you're going the right branch, what is the class label? The class label present over is a no. It means that irrespective of the taxable income, we can say that is no more a cheater. Is not a cheater. So based on this, we can. So this trick is helpful for classifying your data. So the classification is not all about the decision making process. Hence, it is called a decision tree. Now, given a decision tree, now we know that how do we classify with the help of a test data with the test samples. But the question is, how do we construct it? Yes, we construct somehow, but thing is, there are multiple decision trees. So, given a data, so what the statement I made earlier, so given a data, yes, given a data, there exist multiple decision trees. So there could be more than one the tree with the same data. Multiple decision trees are possible. Multiple decision trees are possible. When the multiple decision trees are possible, the question is which one is a good one, right? So that's we'll think of it. So we have to find an optimal the decision tree. So there exist so many techniques to give the decision tree in optimal to get the optimal decision tree. We will use in the literature some systematic approach to get such to remove such ambiguity. I mean to get to come up with a new optimal decision tree. Okay. So our now the focus is how do we construct such decision tree, construction of decision tree. Now let's study about all these things. So before we proceed, I think that yes. So what are the different kind of decision tree? So there is a data. Data is given to you. From this data you have to construct the decision tree. So there are different ways to we can construct decision tree. One is the one of the early inventions was the Hunt's algorithm. It will give the high level view how we can construct the decision tree. And this then afterwards there is a COT. The COT is stands for the C stands for the classification and regression tree. Classification regression tree. And there is ID3 and C4.5, and there is another algorithm called SLIP and sprint. And this won't be discussed, but we will discuss this up to C4.5 versions. Right. Now let's see about the one of the early inventions is called a Hunt's algorithm, but it will give the high level view. So what the Hunt's algorithm says this, let DT be the set of training records that reach a node T. Let DT be the a set of so let so let DT be the set of training records that reach a node T. Right now, it means that the DT be the after part. What actually we are trying to in the high level view means the given original data. Let me explain. Then you will understand what actually. In the high level view, what we are trying to do. So what we are trying to do in the high level view. So this is my whole data set. Whole data set. So we are indirectly partitioning the data set, like the normalization in the, and then a partitioning of data sets. Yeah, doing these partitions until, so how long we have to do this procedure? When when this partition is homogeneous. What is meant by homogeneous partition? The homogeneous partition means all the class label is either yes or all the class label means all the sample will have same class label. All the samples will have same class labels. All the sample will have the class label. Then we can say that such kind of partition is called homogeneous partition. So this partition, so the splitting, this is called a splitting of your data set. Splitting, here splitting, here splitting. So the splitting is done with the help of some condition, with the help of some attribute. This attribute is called splitting condition, splitting attribute or splitting criteria. This criteria is called splitting criteria. It means that this splitting will be varied with respect to the attribute, with respect to the condition. Right. So what is the splitting criteria we are following? So the splitting criteria can be criteria could be ranges. Suppose age, if I am taking, so age is below 20 to 40, something like this. So this is the splitting attribute, and this is a splitting criteria. And something like you are taking taxable income can be greater than 80K. So there, because it could be this one also, because here the attribute is a taxable income, the criteria is taxable income greater than 80K. So it means depending, and we should have splitting attribute and splitting the criteria, and which splitting attribute and which splitting criteria will give this homogeneous partition towards this homogeneous criteria. If I choose towards the end, I will get this homogeneous partition. You have to choose the clever little systematic way. Okay, so that's all about this tree induction algorithms are nothing but decision tree construction algorithm. Okay, so this is the same thing explained here. So let DT with a set of training records that reach at a node T means, so DT means is a data set, the number of samples here is T. The general procedure, if DT contain record that belongs to the same class YT, means that means all the records will have same class YT, means there is no further partition. Then simply create a node, a naive node, and put the class label of all these sample. What the class with S class means S, the no class means no. So what is the class label of all these sample, and for instead of for that you will create a node and you will place you will label with the class label of all the sample which present in that partition. So this is the first step. So there is no further partition here, so that you can stop your procedure. Next, suppose the DT is an empty set. Suppose the DT is not containing any record, then there is no procedure, there is no further partition at all, of course. Then it is a leaf node labeled by a default class. Suppose after doing partition, if you are having a what is called the empty partition, then it's a default node. It came to a default node. And suppose your DT contains a records of mixture. The records means some sample will belong to S class and some sample will have no class. Then you have to use the attribute test to split the data into smaller subsets. How long you have to do? You have to do this procedure until recursively apply this procedure to each subset until you reach homogeneous nodes. Until you reach the homogeneous nodes, right? No. Now let's see how the answer. This is the high level view. Just So for the sample zero, this is a sample decision tree we have constructed with the help of Hunt's algorithm. So you start with the refund. Suppose you start with the refund, then I have done the partition. Then based on the, because of refund, we'll have two type of this categorical values and it's and the splitting will be depending on the type of attribute also. Whether the refund is a categorical or numerical or attribute. So depending on that also the test condition and the, will also vary. Okay, that we will look into now. So the refund here is a what sort of is a categorical attribute because only two category of yes and no. The marriage state is a categorical attribute, but the taxable income is a the continuous attribute or numerical attribute. So hence we will see how do we sort. So there are two categorical values and two one numerical value continuous attribute or is called taxable income. Now let's start our discussion with the refund. And the refund is having only two categories, yes or no. Based on if yes, if you are splitting, so there is no further partition because so after splitting, you will have a homogeneous partition, then there is no partition. Then the refund, the no, the still in the no, then we will pick the next attribute as a marital status in the same order which you have taken in the data set. In other algorithms it differs, but here we can use the next feature. The marital status we have taken, then we have used single and divorced and married, then we got don't cheat and pass. In this case we got a of course homogeneous partitions here. All these are homogeneous partitions. You got homogeneous partitions, and I think these are homogeneous partitions. This is not homogeneous. Further you can divide it with the help of taxable income. You can divide it into for the taxable income. So like this you can do it until you reach the homogeneous partitions. Yes, if you look at after considering taxable income, this is a decision tree, the final decision tree by using Hunt's algorithm. So what you observe, the Hunt's algorithm, the order of the attributes is same as order of attributes in your data set. But in other algorithms, it's not. So now if you look at this algorithm, grid split the records based on the attribute test that optimizes certain criteria. Now if at all, if I want you to come up with the new approaches, the new heuristic approaches, the split the records based on the attribute test that optimizes certain criterion. Means we keep some objective in our mind and to minimize or to maximize that objective, we will split our data set. What is our objective? Our objective is to split my data such that you will create the homogeneous nodes. This is my objective, to create the homogeneous nodes. But the question is, how do we measure this homogeneity? How do we measure this homogeneity? Measure the nodes is suppose this is, as I said, if it all is having S class or is all having no class, we can say it is homogeneous. But how do we measure it? Suppose if it is having some tuple, suppose out of 10, so 9 belongs to S class and 1 is belongs to no class. Means definitely it is not homogeneous, but it is very close to the homogeneous. How do we measure this? What degree of homogeneity is having? So that we have to measure, right? So then only we can do this process effectively, because every time we cannot have a node which is 100% homogeneous. Sometimes you have to compromise to for early termination. So for that, you have to put some threshold on the level of the homogeneity I can achieve. So suppose 90% of homogeneity it is. Here it is 100% if all are S, but it's a 90%. How do you measure this degree? So you must have some measure. So that's what I'm talking about. How do you measure? So in the literature, we will talk about what are those measures are there. Now, so what are the typical issues that we arise when we are constructing the decision or tree induction processes to determine how to split the records? So we should have some systematic approach to determine the records, what is the splitting criteria, what is the splitting attribute and all this stuff. Now, how do we specify the attribute test condition? How do we test means whether it's a category or not, how do we test it? If it's a numerical attribute, the test condition will be differ. Now, how do we determine the best split? That's called homogeneity, measuring of the homogeneity. Determine when to stop splitting means sometimes you have to stop at early stages, and of course, by default, you have to stop your process when you are having homogeneous nodes. Suppose what if you don't have homogeneous nodes? Because maybe you will get when you go in the rigorous when you go in depth, I mean, where you go so many iterations, then you will have a complex decision tree. I will tell you. So if you want to compromise on the on that, then it leads to too much complex decision tree. Then this in turn will lead to some problem. It's called overfitting problem. We will see that. I will discuss. So means to avoid that kind of problem, you should have stopped when early stages. So what could be the typical condition I should have to stop them very early? Okay. Now let us see how do we specify the test condition. So there is an attribute. Depending on the type of attribute, we can decide what kind of test condition I can go with. Okay. Right. What are the different kind of attributes that we typically deals with? The nominal attributes, ordinal attributes, and continual attributes. So we already know what is the nominal attribute. The nominal attributes is called categorical. So this ordinal means it's a categorical plus it is some order in this. So we should follow that order compulsory. The continuous attributes is nothing but numerical attributes. Like in our case, it is a taxable income, and in this case, it is a what is reputation is yes, the first attribute what it is. Yes, the refund, and these are the nominal attributes, and taxable income is a or the what we didn't have I will discuss about ordinal. So then we already seen what is the nominal letter refund and marital status is a nominal attribute. We will see ordinal attributes. So and of course every time it's not compulsory that we have to do only binary split, only two branches. Sometimes it's possible to have multiple branches. Okay, so multiple split is also possible. Okay, two-way split and multiple split. Now, so splitting based on the nominal attribute. Suppose if I'm dealing with the nominal attribute, what are typical kind of splittings are possible? So I can go with the binary split or I can go with the multiple split depending on it how many number of categories are there in that particular attribute. So use as many partitions as a distinct value. So how many partition, how many distinct values, and how many categories are there? So you can go with the so that many partitions. Okay, suppose that many branches are okay. So if there is a car type which is having a family, sports, and luxury, so you can do one partition where the all the cars belongs to family type category, and you will have all the partitions which belong to all the partition. In this partition, you will have all the cars which regards sports category. In this category, in this partition, you will have all the cars which are related to the luxury category. And suppose your algorithm is not supporting multiple split, and we can use the binary split also because there are binary splits also possible by combining any one of the any two. So in that case, what is happening here? You can combine sports and luxury and other as one category. This is one possible binary partition. This is another possible partition is you can combine what is this sports luxury and family sports. Yes, we can combine family and sports, and this is like FSL. The family sports one can. So total. So with this car type, family sports and luxury category, it's then you have a one typical partition is with the multiple split, and this is the another binary split, and this is the another binary split. This is the another. So out of these four splits, this is four partitions. If I can do this partition with like this, I can do partition the binary partition like this. I can do the binary partition like this. I can do the binary partition like this. But out of this, which one is a good? Is you should have some measure in your hand so that you can measure them. Which partition is good? Right. So multiple split. Now let us talk about the ordinal attributes. So now that's the reason I'm taking another example is called suppose size. If I'm talking the size could be small, medium, and a large. But if you look at all the if you, but the partitions of the small should always the part there is some order because the all the partitions all the records which are in the small category will always less than the all the tuples or the sample which are there in the median category. And of course by the same thing apply there exists some kind of orderness and in the small medium and large. But where in the case of sports, if I'm taking the car type sports, luxury, and there is no ordering in that. So it can be any order. But here the small should come first, medium, then after last is the large. This order should have to follow. This is called ordinal attribute. But in this case, so we have some typical cases arise. So now, so what are the typical ways we can do this partition if you have an ordinal attribute? So one is multiple split, and other is binary split. So in this case, small, medium you can combine. In this case, and medium and large you can combine as well. If you look at this particular split, the small and large as combined. It's nowhere we cannot combine because this is order. So in case if the same attribute is ordinal attribute, we have only three possibilities: one multiple split, two binary splits, one multi split, two, one, and binary splits are two. But this is not in a valid partition because this size is an ordinal attribute. Now, what about the continuous attribute? Like a taxable income, which is having a numerical value and which is having a value for each and every possibility in that particular range. So how do we handle this continuous attribute? Because in case of continuous attributes, you will have so many what is called test conditions will arise. So they take taxable income 80k and 81k is possible, 80 greater than 82k, 8 greater than 83k. There are how many number of possibilities you will have? So many possibilities you will have. So many partitions you will possible partitions you can have, and you have to find estimate that particular measure, the splitting homogeneity measure, what is a purity measure, okay, homogeneity or purity measure, homogeneity measure. Sometimes it is also called a purity measure, and you have to measure this homogeneity or purity measure for each and every possible partition. This in turn will have a huge computational complexity at your hand. Now, then how do we handle this continuous attributes? Is one way is you can use the discretization process. What we are trying to in the discretization process is you can convert the given new continuous attribute into the categorical attribute. So the one way is to you can do the discretization process to convert the ordinal categorical into the what is called categorical attribute. So once you have the categorical attribute, so you can apply these procedures. Okay, if it now other way is you can use the as it is. You can directly deal with the continuous attribute with the help of the binary conditions. The binary condition could be if A is attribute A less than B or A less greater than or equal to B, whatever is appropriate. You can use, okay. So in that case, what will happen? You have to consider all possible splits and finds the best cut like this. You have to find each and every possible 80, 81. There are so many cosmos, so it can be more computer intensive because for every combination you have to measure this purity measure value because we don't know which partition is a pure. So right. So splitting based on the continuous attribute. Suppose if we are using binary split, if it's greater than 80k, if it is yes, you go in this partition. If it is no, come to in this partition. Or you can do the multiple split also. So in the multiple splits, you have so many ranges and you can split them in accordingly. Okay, so binary split is also possible and multiple split is also possible for the continuous attribute. Now, then how to determine the best split? So that's what our whole idea, because we know that we are splitting for until we reach the homogeneous. So therefore, where there is a role of purity measure, a purity attribute, okay, purity measure. Now let's see. Before splitting, there are 10 records of the class 0 and 10 records of class 1. So there are 10, 10. So after splitting, if here, so in the left partition, it is having 6 of class 0 and 4 of class 4. And if you look at here, 8 of for class 4, 0 and 0. So if you look, this is a homogeneous. This is very close to homogeneous, and this is not homogeneous, not NH. If you look at, this is not homogeneous, this is not homogeneous. If you look at, every partition is a homogeneous, because there are one record, and that one record is belongs to the any one of the class, then definitely is a homogeneous, because in a partition is all the records that belongs to the same class. Here only one record is there, definitely is a homogeneous. All the records belongs to one class, then it's called a homogeneous partition. Question is, how do we degrade? Okay, then question is, for that we will use three measures. It's called Gini index, and this entropy, and the main idea of the entropy, and based on this entropy we will develop two measures. One is called gain, and other one is the gain ratio. So these two measures are based on the entropy only. So once we understand the entropy, then we will discuss about what is the gain and gain ratio. And this is two measures, the Gini index and gain ratio, very frequently used in the decision tree construction. And some people can also use misclassification error to estimate the to construct the decision tree. So just for a couple of minutes, I will back. Sorry guys, and so there are three measures which will measure the purity of your partition, the purity of your partition. Right. Now let's see one by one. Now, right. Now let's talk about the Gini index, how the Gini index look like. The Gini index formula is the 1 minus summation of all the uh, squaring of the probability distribution. So where P of j by t, the P of j by t is the distribution of what is called jth class or whatever the class. So it's squaring the probability, the distribution. So the P of j by t will be the distribution, now specific class. So square it. So this is called P of j by t all square. Now let's see. Now the P of j with relative frequency of the class j at node t means the jth class distribution. So how many samples out of t, how many samples are belongs to the jth class is talking about P of g by t, right? So that is nothing but the probability value or probability distribution. Yes. Now, so with this case, suppose all the records are equally distributed, there are t records and they are equally distributed, then what will happen? This will turns into the 1 minus 1 by nc. The maximum value of the Gini index is 1 minus 1 by c. This can occurs only when the distribution. So when there is a partition, so in this partition, this partition will have equal number of what is called samples, equal number of classes, equal number of samples. Then the maximum Gini index value is 1 minus 1 by t, and it will be least information when we it will have a least value is 0.0 or 0 when all the records belongs to the one class, implying the most interesting information, because this is what we are interested. We want a partition in which you should have all the records belongs to any one of the class. If you look at here, in this case there are 6 records, all the 6 records belongs to class 2. Out of 6 records, 1 record belongs to class 1 and class 2, very close to the act. So this is 2 records that belong to class 2 and class 1. There are 3 records belongs to class 3 and 3 records to class 2. If you look at in this, all the records of it, so the Gini index of this value will be definitely 1 minus 0 by 0 whole square plus minus 6 by 6 whole square. Nothing but 1 minus 1 whose value is 0. The similarly, this is 1 minus 1 by 6 whole square minus 5 by 6 whole square, because 1 minus summation of the distribution. The distribution of the class 1 is out of 6, 1 is there, so 1 by 6, and the distribution of the class 2 is 5 by 6. So if you simplify, its value is 0.278 definitely. In the similar, it is 1 minus 2 by 6 whole square minus 4 by 6 whole square, which is 1 minus 3 by 6 whole square minus 3 by 6 whole square. In this case, what is the problem? It matches with this case because the equal number of distributions are there. It is 1 minus 1 by nc value. What is the one nc value? 1 minus nc, number of classes 2. So 1 minus 1 by 2 is 0.5. It is as 0.5. So this will map to this, and the last case is mapped to the first case. Okay. Right? It's very simple. Now the same thing. So how I calculated Gini, the same thing I kept displayed here, the 0 and 0.28 and 0.44 and this 1 minus 1 by Cn case. Now we seen this Gini index is used in CART, SLIC and sprint algorithm. So what are the algorithms are there for decision tree construction? These decision tree based algorithms will use the following decision like CART and SLIC and sprint are used in the Gini index. Now how they will use the Gini index, we will see now. Suppose what we are trying to do, so there is a split. There is a data split. We know whether this is a pure or whether this is a pure. But the question is, my estimation is whether this partition is a good one, best partition or not. How do I identify? So that, so this is a slightly, you make use of this Gini index. Again, the Gini of individual compo partition, so Gini of this and the Gini of this, and it's a weighing factor. So the weighing factor will be the out of n sample, how many are on the left branch and how many are on the other branch, and summation of I is equal to such summation. The weighing factor is multiplied with the corresponding Gini, and summation of all such Gini is you get the Gini of the split. So the Gini of the split should be minimized. So the which split will have Gini split is minimum. So that is called what is called? That is called the best split. So now I am using Gini, making use of Gini, we are identifying the which is the best split. To identify the best split, you have to use this formula. In that formula, what we are trying to do? The Gini of individual components, there are k branches, 1, 2, 3, 4, and so on. There are k branches. The Gini of individual and corresponding weighing factor. The weighing factor will be Ni by N. This is the weighing factor. Now let's see for this partition. So what is the Gini? So once we know how to calculate the Gini split, for every possible split, you can identify the Gini split. You can identify which one is the minimum. Having a minimum Gini split, that is the best one. Okay. Now let's see the Gini split. So now there are 6 records that belongs to parent. In the actual before partition, this is the distribution. There are 12 records, and out of this, there is a 6 records belongs to class 1 and a 6 belongs to class 2. Now, after the splitting, the out of 6, 5 is going to the class 1 in the node 1, and 1 is going to the in the node 2. The out of 6 belongs to the class 2, 2 are going to the class 2, and 4 are going to class 1. Now, let us find the Gini of this and Gini of the split, Gini split. Now, Liz, what is the Gini of N1? So, 1 minus, it's not 5 by 7, it is a 5 by 6, because out of 6 records of the class 1, this 5 are in the left branch, in the node N1. So, 5 by 6 whole square minus 2 by 6. Out of 6 records of class 2, it belongs to the 2 records, are there in 2 records in the left branch. So, minus 2 by 6 whole square. So, this is minus 0. The Gini of this particular is 0.194. And similar lines, you will get the 0.528. But what is the Gini of the split? You know what is the weighing factor? The weighing factor will be 5 plus 2, 7. Here the 7, this is the 5 out of 12. The weighing factor will be 7 by 12 and the 5 by 12. You will get 7 by 12 into 0.59, 0.94, 5 by 12 into 0.528. You will get 0. The Gini of this particular split is 0.333. The whose Gini split is minimum, so that is the best split. So now we have arrived a solution for finding out the best Gini split, right? Now, so far we dealt with the categorical attributes, and maybe now what is the case if it is having a continuous attributes? Category attribute computing Gini index is very easy, and just what is called you take what are the possibilities. If it is the multiple split, what is the Gini value, which is the Gini split? There are 3. So, and if it is a 2-way split, and out of this, and the Gini value is 0.4 or 0.418, and the least one is this means for the core type Gini, the splitting, the multiple split is better than the binary split. Okay. But if it is a categorical value, but if the numerical value, we will discuss now. So, now, how can we handle the continuous attributing? How do we compute the Gini index and the continuous attribute? Now, let's see how do we solve it. So, use binary decision based on the one value. So, as I mentioned, A greater than B or A less than or equal to B. You can use any one of this binary condition to split the binary, what is called continuous attributes. But there exist multiple values of what is called this continuous attributes. A, suppose taxable income is 80K. It could be 81K, greater than 81K, greater than 82K, greater than. There are so many possibilities that will be there. For each and every possibility, you will have corresponding Gini index. The several choices for splitting value. But to limit the number of splittings, what we are trying to do, the number of possible splittings, we are limiting by the number of distinct values. Just consider the number of distinct values. So what is the number of distinct value here? So 125, 1. So this is new, and 70, and 120 is new, 95K is new, 60, 224K and 85K, and everything is a distinct value. There is no repetition of the taxable income. So there are how many distinct? 10 distinct value. Hence, we will have 10 splits. For each and every split, we will have the Gini index. So each splitting value has a count matrix as well with the distribution matrix. So if suppose the taxable income is greater than 80K, the corresponding we will have yes and no disturb. Then out of when I keeping the taxable is greater than 80K, how many comes to the S class? How many belongs to the no class? This is the called distribution. So this distribution matrix or count matrix will be helpful to find out the Gini index. So the class counts in each of the partitions. Yes, the simple method to choose the best V is that for each V, scan the database to gather the count matrix and compute its Gini index. So if there are 10 distinct values are there, you have to compute the Gini index 10 times. For every time you are calculating, so you have to scan for the entire data set. Isn't it or not? Because even if you for greater than 80K, you have to scan entire data set. And for greater than 90K, you have to scan entire data set. Because the number of times you will go through the scan, scanning of this data set is more number of times, and it is a computationally inefficient. So what is the alternative? Can anybody guess? How can I reduce this number of scans? Number of scans, how can I reduce it? Can I reduce the number of scans? Simple idea. Any guesses? No? Just apply the sorting over here. Just apply the sorting over here. That's my next slide. Yes. So for efficient computation for each attribute, the sort each attribute in the sense for each continuous attribute, sort the attribute on the values. So what is the advantage when you sort it? Suppose the 80k, 90k. Suppose when I'm interested to find greater than 100k. So what is happening? So I only look for the all the tuples which are above this, because I need not to scan this particular part region, because I'm sure that in the search space I don't find any taxable income value which is less than which is greater than 100k, because we already sorted. But where in the earlier case it is in jumbled in order, we don't know whether it's in the beginning or is the middle or in the last. So that's the reason you have, for every thing you have to scan from the top to bottom. So that's why. Okay. Like linear, what is called a linear search and binary search. Right. So linearly scan these values each time, updating the count matrix and computing the Gini index, and choose the split position that has the least Gini index. So the same thing, suppose if the taxable income is our distinct values, now we sorted with respect 60, 70, 75, 85, 90, 95, 100, 120, 125 and 220. So what we did, we have created, now the question is A greater than B or A less than or equal to B. So based on this we are doing binary splittings. Now, what is the splitting value is? The splitting value could be the average value of the two successive values. What is the average value of this? Average value of these two, 60 plus 70. So 130 by 2, 65. 70 plus 75, 135, 72.5. So 72 or 73 you can take. 75 to 85, 160. The average value is 180. Something like here also you will get 172. And you take some value greater than 220, say 230, one value less than the 60, you can take 50, and you can, based on this you can get the count matrix. Suppose if the taxable income is the less than or equal to 55 or greater than 50. If it is less than or equal to 50, come to the left branch. If it is greater than 55, go to the right branch. So when you're doing this, when you're scanning from the database, this is your what is called count matrix distribution. Then once you have count matrix distribution, then this is a distribution, you can count the what is called Gini index value. What is the Gini index value? So 1 minus summation of probability distribution, 0 by 6. 1 minus out of how many? 10. So there are 10. So this is 3 by 10 whole square minus 7 by 10 whole square. This value 0.42. So like this you will get for each and every distribution, you will get it. And then you will get the Gini index of all these possibilities. Then the Gini index of the minimum is here. Out of all these possible splittings, the Gini index is minimum if the taxable income value is the greater than or equal, less than or equal to 97k, it's coming to left branch, less than or equal to 77, and greater than 97, go to the right branch. Okay. So this is the best split. Now, so let us take some 10 minutes break. Then we will resume our session with the another splitting measure is called entropy. Okay. Any doubts so far? I mean, so let's have some 10 minutes break. Then we will resume our session with the new splitting measure is called entropy.